Good morning, students. Welcome to JGS online class for grade 12 physics. Let us start. Already we started with chapter 1, electric charges and fields. Now let us learn about conductors and insulators. So what is the main difference between conductors and insulators? First let us learn about conductors. We know very well usually metals are very good conductors, right? These are the substances through which the electric charges will flow very easily, and they contain, because the reason is the valency electrons are more in the conductors and they contain large number of free electrons which make them the good conductors of electricity. Okay, so these conductors they conduct electricity and they are very good conductors. Which are very good conductors? Metals are very good conductors. Human bodies, animal bodies, etc. are very good conductors. Graphite is a very good conductor. All acids and alkalis are considered to be good conductors. Right? Now, what are insulators? So, this is a reverse of conductors. These are the substances which does not allow the electric current to pass through them. Why? What is the reason? Why they are not allowing the flow of current easily? The reason is, we already have understood that in the case of conductors, there are large number of free electrons present, so that there is no resistance for the free flow of electrons. But here, there is, in the case of insulators, there is absence of free charges, which offers very high resistance for the flow of electricity. Example is glass, diamond, porcelain, etc. Now we are learning about the electrostatics. What is electrostatics? It is nothing but frictional electricity. Okay. Now the study of frictional electricity is also called as electrostatics. In the electrostatics, why are we learning about conductors and insulators? The reason is how these conductors and insulators are behaving in the case of electrostatics when the charges are present on the surface of insulators and conductors. Now, let us take for example of conductors. When you take the main important difference between the conductors and insulators in terms of electrostatic is this. This is the main reason. So, the difference is when a few charges are allowed to pass on the surface of a conductor, immediately that charges will get distributed throughout the conductor. That means all the charges which are present on the surface of the conductor will not stay at a particular point, that will be distributed throughout the conductor equally and also uniformly. But in the case of insulators, when few charges are present on the surface of an insulator or allowed to pass on the surface of insulator, they will not move, and wherever they are present, they will be present in that particular place. So there won't be any readily distribution of charges in case of insulators. But in the case of conductors, they will get readily distributed. Right? So this is the main difference. So we have to understand, as we are already learning about the transfer of electrons from one surface to other surface. This is very important for us to understand the major difference of conductors and insulators in terms of electrostatics. Right? So what we have understood, in case of conductors, when the charges present on the surface of conductor will be distributed uniformly throughout the conductor, and in the case of insulators, they will stay at that particular place without any uniform distribution. Right? Now, the next concept is electrostatic induction. What is the process of induction? How can we induce the charges in a conducting rod? What are the different methods? Already in the previous examples, we have learnt how a particular glass rod was charged, and similarly a plastic rod was charged by rubbing or through friction. Now let us see, this is another method of charging a particular conducting rod or a conductor. In this process of electrostatic induction, a conductor can be temporarily electrified, in which when a charged body is brought near a conductor, what happens? The opposite charges will appear at the near end, and same charges at the opposite end. So that what happens? This conductor will act as a charged body having opposite charges at one end and same charges at the other end. Okay, now this process in which the positive and negative charges produced at the ends of the conducting rod are called as induced charges. So what are the usually two types of charges produced? Positive and negative charges. These two charges will be seen at the two ends of the conductor. If a positively charged body is brought near, negative charge will be seen near. Okay, seen near the conductor. If a negatively charged body is brought near, positively charged is seen in the conductor at the near point, right? And these charges on the glass rod, which induces these charges on the conducting rod, is called inducing charge. Okay, now let us see in detail how the two spheres will be charged by the process of induction. Now let us see a small experiment to understand the process of electrostatic induction. Right? Now in case A, hold the two metal spheres on insulating stands and place them in contact. So in the figure also it is shown the two spheres are in contact with each other. When they are in contact with each other, it will be considered as a single conducting rod, right? Or single conducting sphere. Okay, now in the case B, what is done? A positively charged glass rod is brought near, and it brought near the first conducting sphere. So, according to the process of induction, what did we learn? We have learned that when a positively charged body is brought near the conducting rod or conducting sphere, opposite charges will be seen at the near end and the same charges will be seen at the opposite end. That is what we understood in the case of electrostatic induction. So in the figure B also, it is observed that when a positively charged glass rod is brought near the first conducting sphere, negative charges, now both the spheres are considered to be a single conducting surface, right? Now, because they are in contact with each other, right? Now, when the positively charged body is brought near, that need not come in contact. When it is brought near, then immediately you will observe the negative charges at the near end and positive charges on the opposite end, right? Now in case C, what is done? The two spheres are separated. When two spheres are separated in the presence of the glass rod, already first sphere has negative charges on it and second sphere has positive charges on the opposite end. So both will be separated. Negative charge will be separated and also positive charge will be separated over there. Now in case 4, the glass rod which is positively charged is separated from the spheres. Then what happened? Immediately the negative charges which are present on the first sphere have moved towards the opposite end and positive charges which are present on the second sphere have moved towards the opposite end. That means there is transfer of charges. We already have understood in the previous topic that how the conductor will transfer the electric charges. In the conductor on the surface, electric charges will move from one place to other place, right? Now, in the case D also, there is transfer of charges from one end to other end. That is what observed in the absence of external charged body, that is external glass rod, right? Next, in the case 5, both are separated, both are still separated, both the spheres are still separated, and we have already understood that there are negative charges on the first sphere. These negative charges got transferred or uniformly distributed throughout the surface. See how they are distributed throughout the surface. So, first sphere has become negatively charged by uniformly distributing all the charges on its surface. And then the second sphere became positively charged by distributing all the positive charges on its surface. So this is a temporary process, and this process is called as electrostatic induction. That is just temporarily inducing the electric charges on a conducting body. Any conducting body, either it is a conducting rod, or it is a conducting sphere, whatever it may be. Okay, now here both the spheres are brought near in contact in the first case, and in second case, when they are in contact with each other, a charged body is brought and two opposite charges are seen on two spheres. And in third case, in the presence of the external charged body, both the spheres are separated with opposite charges. And in the fourth case, external charged body is removed and both spheres have redistributed the charges. And in the fifth case, both the charges which are present on the surface of the spheres got redistributed and uniformly distributed throughout the surface. And now these two spheres are acting as temporarily charged bodies, right? This process is called as electrostatic induction. Okay, now in this experiment, this is another experiment which shows the various steps involved in inducing a positive charge on a metal sphere, right? So, how to induce a positive charge on a metal sphere? See the different cases here also, case A, case B, case C, and also case D. Here, in case A, again like previous experiment, hold a metal sphere on an insulating stand, right? And bring a negatively charged plastic rod near it. Bring a negatively charged plastic rod near it. According to the process of induction, we already know that when a negatively charged body is brought near the conducting sphere, opposite charges will be seen at the near end and same charges will be seen at the opposite end. That is what is observed in the figure in case A, right? So, the metal sphere has positive charges at the near end and negative charges at the opposite end, right? Now, our aim is to make the metallic sphere a positively charged body, right? So, what should be done? The negative charges need to be removed. Now, in case B, what is done? In the presence of the plastic rod only, the opposite side of the of the conducting sphere is grounded. So, what charges are present on the opposite end? Negative charges are there. All these negative charges will pass through the ground and only positive charges will be left on the metallic sphere at the near end of the plastic rod, right? Now, in the case C, what is done? What is observed? All the negative charges already got transferred to the ground. Only positive charges are left on the near end of the plastic rod. Okay, now remove the plastic rod. When the plastic rod is removed, what usually in the previous experiment, what did we observe? All the charges which are present on the surface of the conducting rod, that is all the positive charges which are present, will get redistributed. This is how in the last case, that is in the case B, all the charges will get redistributed throughout the surface by the process of induction. That means in this experiment, we have understood how a metallic sphere by using the process of induction can be converted into a positively charged body. If it has to be converted into a positively charged body, then what should be done? Negatively charged plastic rod should be brought near. If our aim is to make a metallic sphere into negatively charged body, you might have understood what should be brought near, what type of charged body is brought near. A positively charged body, that is a glass rod, positively charged glass rod, if it is brought near, negative charges will be seen at the near end and all positive charges will be seen on the opposite end. If all positive charges are grounded and the glass rod is separated from the sphere, negative charges will be redistributed on the surface. These are the different methods how we can make a conducting sphere into a charged body by the process of induction. Right? These are the different methods, different experiments which help us to understand the process of electrostatic induction. Now, this phenomenon of electrostatic induction also help us to understand the working of goldleaf electroscope. Goldleaf electroscope is a device as shown in the figure. It is a device used for detecting an electric charge and also identifying its polarity. So, what is the construction of this goldleaf electroscope? It consists of a vertical conducting rod passing through a rubber stopper fitted to the mouth of a glass vessel. And at the end of the rod, two thin gold leaves are attached to lower end. And also, when the charge, there is a metallic knob at the top of the conductor. Okay, now when a charged body is brought near the metallic knob, the charges will passes through the conducting rod, and the two gold leaves which are present at the bottom will acquire the same charges. If a positively charged glass rod is brought near, both the gold leaves will acquire positive charge by the passage of positive charge from the conducting rod to the gold leaves. If a negatively charged body is brought in contact with the conducting rod, both the leaves will get the negative charge. So whatever it may be, when a charged body is brought near, that charge passes through the gold leaves, and both the gold leaves will acquire same charge and they start diverging with each other. The leaves diverge due to the repulsion of the like charges they have received, and the degree of divergence of leaves gives the measure of amount of charge. If the charged body brought near is very strongly charged, then the divergence of leaves will be more, and if it is not very strong, the divergence will be less. Okay, so the repulsion of the two gold leaves will give the measure of amount of charge present on the conducting rod. This is the instrument which is called as goldleaf electroscope. Now, let us know about the electrostatics. So, electrostatics is nothing but frictional electricity. It is the study of electric charges at rest. Now, we study the forces, fields, potentials associated with the electric charges in the static electricity. There are different applications found in industrial purposes in case of electrostatics. Like, what are the different applications we usually observe? They are used in electrostatic loudspeakers, electrostatic spraying of paints and powder coatings, and in ash collection in chimneys, Xerox copying machines, and in the design of cathode ray tubes used in the television, radar, etc. Thus, there are different applications of electrostatics in industries. Next concept, let us learn about the basic properties of electric charges. There are three basic properties of electric charges. First one is called additivity of charge. Second one is the quantization of charge. And the third one is the conservation of charge. First one, let us learn about additivity of charge in detail. Like mass, electric charge is a scalar quantity. Just as the mass of an extended body is the sum of all the masses of its individual particles, the total charge of an extended body is also the algebraic sum of all its individual charges located at different points inside it. Thus, electric charge is additive in nature. Let us take, for example, there are different charges present in a body like Q1, Q2, Q3 and so on. The total charge in the body is Q is equal to Q1 plus Q2 plus Q3 and so on Qn. This is how it follows the property of additivity. Let us take an example here. If Q1 is equal to 2 microcoulombs, Q2 is equal to minus 3 microcoulombs, Q3 is equal to minus 2 microcoulombs and Q4 is equal to plus 3 microcoulombs. Then what is the total charge? Now there are 4 charges in a body. The total charge Q is equal to, according to the additivity of charge, it is Q1 plus Q2 plus Q3 plus Q4. That is 2 microcoulombs, minus 3 microcoulombs, minus 2 microcoulombs and plus 3 microcoulombs. So the total charge is equal to 0. Thus the total charge on the body is equal to 0. Thus this is how the electric charges follow the property of additivity. Right? Next property is called as quantization of charge. What is meant by quantization? Quantization of a physical quantity means that it cannot vary continuously to have any arbitrary value, but it can change discontinuously to take any one of the discrete set of values. For example, let us take in the case of a building. Let us suppose there are different floors, first ground floor, first floor, second floor and so on. But between ground and first, there is ground floor and first floor. Between ground and first, there is no separate floor, right? Thus, the energy of an electron in an atom or the electric charge of a system is also quantized like that. See, if there is only one charge, its value is 1.6 into 10 power minus 19 coulombs. If there are two charges, its value is 2 into 1.6, that is 3.2 into 10 power minus 19 coulombs. That means if there is only one charge, the magnitude is 1.6 into 10 power minus 19 coulombs. If there are two charges, the total charge is 3.2 into 10 power minus 19 coulombs. There is no separate charge in between 1.6 and 3.2, right? So this is how the charge is considered to be quantized. So how can we explain that quantization? It is the experimental fact that electric charges occur in discrete amounts instead of continuous amounts, and it is explained by using the formula Q is equal to N into E, where Q is the total charge on the body and N is the whole number which takes up the values. N is equal to 0 plus or minus 1 plus or minus 2 and so on. E is the charge which is equal to 1.6 into 10 power minus 19 coulombs. Understand? Now, this quantization of charge is an experimentally verified law. It is experimentally verified in the laws of electrolysis discovered by Faraday, first suggested the quantization of electric charge. Similarly, in Millikan's oil drop experiment also it is explained. So, this is an experimental fact. Okay. Now, the main important thing which we have to understood and note down or remember it is, usually this quantization of charge is considered in the microscopic level but not in the macroscopic level. Let us see why what is the reason. While dealing with the macroscopic charges, we can ignore the quantization of electric charge. This is because the basic charge is very small and N will be very large in most of the practical situations. Like, for example, let us take an electric bulb having 60 watts power. That means in such a case, nearly 2 into 10 power 18 electrons will pass through its filament per second. That means N value is very high, which is 2 into 10 power 18. So, here the structure of charge does not show up or the bulb does not flicker with each and every entry of each and every electron here, because there are so many electrons present over there, nearly 2 into 10 power 18. For every entry of electron, the bulb will not flicker, showing the quantization of charge. So that means in the macroscopic level, the quantization of charge will be negligible. It will be considered only in the microscopic level. Understand? So quantization of charge becomes important at the microscopic level, where all the charges involved are in the order of tens or hundreds, etc. Right? Now, the last one is a conservation of charge. What is conservation of charge? This shows that on an isolated system, the total charge remains constant. That means the charges can neither be created nor be destroyed, but it can be transferred from one surface to other surface. There are different examples like glass rod, charged glass rod. How a glass rod is charged? by using the silk cloth. When a glass rod is rubbed with the silk cloth, it develops a positive charge. At the same time, silk cloth develops an equal negative charge. Thus, the total charge or the net charge on the glass rod and the silk cloth will be 0. Similarly, let us take one more example like sodium chloride. Sodium chloride ionizes into sodium ions and chloride ions. Right? So, sodium ion is a positive ion and chloride ion is a negative ion. There is a transfer of charge from sodium to chlorine. Sodium loses one electron and chlorine gains one electron. So that sodium becomes positively charged and chlorine becomes negatively charged. Right? So the total charge is 0 before and after the ionization. So that we can say that charge is considered to be ionized. Similarly, one more example we can take, that is fission of uranium. So in the fission of uranium, when a slow moving neutron is bombarded with uranium nucleus, it splits into 2 moderate nuclei like barium and krypton. And 3 fast moving neutrons along with a large amount of energy will be released. When you see the total atomic number on the left hand side and also on the right hand side, it is equal to 92. Right? And similarly, total mass number is equal to 236 on left hand side and it is 236 on the right hand side also. So that we can say that total charge before fission is equal to total charge after the fission. Thus, these are the 3 different properties possessed by the electric charges. Those are additivity, quantization of charge and conservation of charge. Right? Now, coming to the one more concept, that is effect of speed on mass and electric charge. According to the special theory of relativity, mass of the body increases with its speed. This is understood by using the formula given below. M is equal to m naught into by under root 1 minus v square by c square. In this, what is m? M is the mass of the body which is moving with speed v. M naught is the rest mass of the body. V is the speed of the body. C is the velocity of the light. So, velocity of the light will be all the time more than the speed of the body. So, V is very less compared to that of C. So, when you substitute in the above equation, we will have M is greater than M naught. That means mass of the body increases with the speed. In contrast with that, charge of the body will always remain constant. Right, students? Students, at the end of this session, please answer these assignment questions. First one, what is the cause of charging a body? Second one, why does an ebonite rod get negatively charged on rubbing with wool? Third one, what is the cause of quantization of electric charge? Fourth one, is the total charge in the universe conserved? Fifth one, what is the least possible value of the charge? Sixth one, when a polythene piece is rubbed with wool, it acquires negative charge. Is there any transfer of mass from wool to polythene? Please answer these questions.